let's start our seminar. And our plan is following. First of all, I try to explain the solution of some of the problem of the test and say about the result of this test. And second part will be devoted to quadratic surfaces, and we consider one of maybe a little more problem which connected with surfaces. Yeah. What trace?
The scores from the test.
Squares for the test. Yeah. I'm going to say about this. The most hard of the problem in the test was the first problem, and we consider the solution of this problem. The result, the test, the following. Vahid Dasgerdi 3 score, Reza Aliasgari 2 score, Haidar Abdulkader 6, Rehman Abdul 1, Ali Ibrahim 2, Olivera Rasha Gomes 4, Soares Rosenberg 6, Da Silva Kevin 4. We have 4 problems, and each of them was estimated by 2 scores. And if you have partial solution, we can obtain only one score. The result Vahid Dasgerdi true with partial mistakes 1 and third problem. Late problem is absent, and second has mistake. Reza Aliasgari. Yes, in partial. If was given the full solution, we obtained 4 score. But now we discuss the main mistake in the first problem. Yes. And I'm going to discuss this problem, the first problem. Maximum
6 from 6.
Maximum 8. 8, maximum 8. But nobody can obtain the maximum. 6. Soares Rosenberg, and he solved second, third, and fourth problem. But first problem was absent in your solution. And all give some mistake in solution of the first problem. In my opinion, the first problem was enough simple, but in my opinion, strange mistake. I recall, if we have 2 bases, old bases, E1, E2, E3, and new, basis U1, U2, U3, and we have some matrix C which expressed the new basis in terms of old basis by the following form. We multiply matrix row U by this matrix C. It means that U1 is equal to C1, 1, E1, C2, 1, E2 plus C3, 1, E3, U2. You have the following formulas, and in the matrix formalism we have the following expression. But from this formula we obtain the formula which related the coordinate vectors in the old basis and in the new basis. If we have vector Ex and this vector has a coordinate x1, E1, x2, E2, x3, E3, and x tilde 1, U1, x tilde 2, U2, x tilde 3, U3. And we have the following relation. The old coordinates x, the old coordinates x1, x2, x3 can be obtained by multiplying the new coordinate by the matrix C from the left. Exactly, we have the following formula, which has the same form as the previous. C 1, 1. Easy to see that the two type formulas is the same, but in the case of coordinate, we transpose this expression. We can see that this coefficient C, the upper indexes 1, 2, 3, but in this case down indexes 1, 2, 3, but upper index is fixed. is equal this upper index. In this case, down indexes is fixed, but change upper indexes. We summarize but intersected indexes, intersected type indexes. Up, down, up, down, up, down. In this case, down, up, down, up, down, up. And if we have the coordinate of the point, this formula is changed the following way. We can edit the coordinate of the origin of the new coordinate, the origin of the new coordinate system in the old coordinate system. And we can edit the coordinate of the origin. And this is the main formula for the solution of the first problem. We have in the condition of the first problem, we have the triangle pyramid. First step to express the new basis in terms of the old basis. We have arbitrary triangle pyramid. A, B, C, D. And let M be the center of the mass of the face B, C, D. The center of the mass is the intersection point of median of this face. This face is a triangle, and M be the point intersection of the point intersection of the medians of this triangle. In the old coordinate system, S as the origin of this coordinate system, point A, and basis vectors. Bases are vectors AB, AC, and AD. You have AB, AC, and AD, the old coordinate system. The new coordinate system, the origin M, MB, MC, MA. MB, MC, MB, MC, MA. And we can, to express these vectors M, B, MC, MA in the terms vectors A, B, AC, AD. In our example, E1, AB, E2, AC, E3, AD, and U1, MB, U2, MC, U3, MB, MC, MA. And origin M and coordinate of this point M is equal coordinates of the vector AM. Easy to see that vectors AM is inverse to the opposite to the vector MA. M be the intersection point of median. I'm not sure, but it seems to me that we consider the formula which express coordinates of the point intersection of the median in terms of coordinates of the point which vertex of the triangle. And this formula was the following. AM is equal 1 divided 3 AB plus AC plus AD. In the terms of the old basis, we obtain that coordinate of point M 1 divided 3, 1 divided 3, 1 divided 3. By definition, what does mean that coordinates of the point M is equal x, y, z? It means that vector OM can be expressed as linear combination of basis vectors with coordinate x1, x2, e2, x3, e3. In our case, these vectors e1, this e2, this e3. And coordinates of the vectors AM exactly equal to the coordinates of the point M, of the origin of new coordinate system. It means that in this formula, the coordinates it's x0, 1, x0, 2, x0, 3 exactly equal 1 divided 3, 1 divided 3, 1 divided 3. We obtain the first summons. Yeah. The question. What? I don't understand exactly. What's
you wrote M, the coordinates of M is 1, 3, 1, 3, and 1, 3.
Yeah.
How do you know this?
How? Yes. I repeat. This is the important fact. This fact reflects all system of notions. I repeat.
This is the formula?
Yeah. Okay. What in this formula? This coordinates is exactly coordinates of the origin of the new coordinate system in the old coordinate system. This coordinate of the point. In our case, the new origin is the point M. And these numbers are coordinates of this point. What does mean the coordinate of the point? By definition, if we have arbitrary point N, what does mean that coordinate of this point x, y, z? What does mean? By definition, we have some coordinate system or reference system. This coordinate system has the origin, point O, and the bases, E1, E2, and E3. If you consider arbitrary point N, we connect with this point the so-called radius vector ON. And by definition, the coordinate of this vector exactly the coordinate of the point N. By definition, coordinate point N are the coordinate of its radius vector, ON. What does mean the coordinate of the vector? By definition, the coordinate of the vector is a coefficient of the linear combination which present this vector as linear combination of the basis vector. We must decompose this vector on the basis vector, present this vector as the linear combination of these vectors, namely ON is equal x E1 plus y E2 plus z E3. These coefficients x, y, and z are uniquely defined by the condition that these vectors E1, E2, E3 is a basis. What does mean basis? By definition, basis is such set of the vectors that any vectors in the vector space can be uniquely decomposed and uniquely present as a linear combination of these vectors. For any vectors exist a unique such presentation as a linear combination, as uniquely defined coefficients of this linear combination, which present our vectors as a linear combination of the basis vector. Each coefficients are called coordinates of the vector. And using this main definition, we try express vector OM in terms of the basis vector E1, E2, E3 of the old coordinate system, of the old basis. In our example, old basis, which consists of the vectors AB, AC, and AD. These three vectors form the basis. And our goal to express vector OM as a linear combination of these three vectors. And we obtain the following expression. AM is exactly equal the sum of these vectors divided on 3. This fact is true for any point of intersection. If the M be the point of intersection median in the arbitrary triangle, and x1, y1, z1, x2, y2, z2, x3, y3, z3 be the coordinates of the vertices of this triangle, the coordinate of this point x prime is equal 1 divided third x1 plus x2 plus x3, and so on. This is a consequence of the following fact. If this point A, B, C, M, vector OM is equal 1/3 OA plus OB plus OC. The consequence of this fact. We can easier to prove this fact. For example, vector AM. Let A1 be the middle of the segment BC, and easy to see that the vector A1 is equal half of the sum AB and AC. Okay. I try to explain in detail this formula. We have triangle A, B, C. A prime be the middle of the side BC. M, B, the intersection point of the median. We have the following two facts. First, A1 is equal half AB plus AC. Do you understand?
Yes.
Yes, we have parallelogram, and if we continue this vector, and we obtain twice vector, and this vector is the diagonal in this parallelogram. And this vector is half of this diagonal. And we have the following fact. The second fact, AM is equal to 2 divided 3, A1. We have the following theorem. The point intersection divided any median in the relation 2, 1. And this length is half 2 divided 3 of this. Do you understand?
Yes.
Yes. Okay. And if we substitute this formula from this formula, we obtain that A1 is equal 1 divided 3rd AB plus AC. AB plus AC. Okay, if we have some point O, this point can be the origin of a new coordinate system. Our aim expressed this vector in the term of these vectors. Easy to see that vector A1 is equal O A1 I'm sorry. Vector AM, excuse me, AM. I substitute in this expression, AM. And vector AM is equal difference OM minus OA. And this equal 1/3. AB is equal difference OB minus OA. AC is equal OC minus OA. And we obtain that OM is equal OA plus 1/3 OB minus 1/3 OA plus 1/3 OC minus 1/3 OA. And we obtain OA minus 1/3 minus 1/3 OA minus 2/3 OA. We obtain 1 divided 3 OA plus 1 divided 3 OB, 1 divided OC. And we obtain the following formula: OA plus OB plus OC. We will use this formula. Do you understand?
I see, yes.
Yes. And in this case, this vector OA, OB, OC be the vectors of the basis. And by definition of the basis, we obtain that the coordinate of the point M is equal 1/3, 1/3, 1/3. Do you understand?
Excuse me. The first line you wrote A1 is equal to 1/3.
The first line
No,
in this?
That one.
This?
Yes.
Yes.
First
one, or this one?
Up. You wrote.
This one. This one. Yeah. Okay.
One more.
This 1 divided 2. This 2 divided 3. And if we substitute in this formula this, we can multiply 1 divided 2 and 2 divided 3. And we obtain 1 divided 3. Yes. And we obtain this formula. And after them, I change AB by the difference OB minus OA. AC is equal OC minus OA. And I transfer OA in the right side and change sign. And we obtain final expression. And we can subtract from OA 1/3 OA, 1/3 OA, and we obtain 1/3 OA.
Thank you.
Okay. In this first step, we obtain this expression: 1/3, 1/3, 1/3. What? And second step is to express the coordinate of the new basis in the term of the old basis. New basis. Excuse me. New basis. The new basis MB, MC, and MA. And old basis AB, AC, and AD. And we must express these vectors in the terms of this old basis and this new basis. The vectors E and this vectors U. And after them, we will use this formula and this formula. And easy to see that MB, for example, MB is equal to the difference AB minus AM. MB. M minus AB. MC U1 U2 MC MC AC minus AM. Wait, I'm sorry. AB minus AM. We must subtract from the vectors with endpoint B the other vectors with endpoint M. AB minus AM, AC minus AM, and U3M MA. AB is equal E1 minus AM. AM answer divided E1 plus E2 plus E3. AC E2 minus 1/3 E1 plus E2 plus E3. MA minus 1/3 E1 E2 plus E3. And we obtain the following. We obtain the following formula. E1 minus 1/3 E1 and 32. We obtain 2 divided 3 E1 minus E2 minus 1/3 E3. In this case, minus 1/3 E1 plus 2 divided 3 E2 minus 1/3 E3. And in this case, minus 1/3 E1 minus 1 E3 minus E2, sorry, E3. We obtain the matrix C. We can write this matrix, we obtain this formula. This formula is exactly this. I can substitute this expression in this formula. And matrix C is equal these numbers, which we can see as written in the column. We must write as the first row. 2, 3 minus 1 divided 3 minus 1/3. This row is exactly equal to these columns. And these columns is exactly, and this we obtain the following formula. Easy to see that we obtain symmetric formula, but in this case, after transposition, this matrix will not change. This final, we must substitute this expression and this in this formula, and we obtain the final result. The final result. The final step to substitute in this formula the result of our calculation. And we obtain the coordinates x1, x2, x3 is equal the coordinate of the the region of the new coordinate system, namely the points, the coordinates of the point M, which is equal 1/3, 1/3, 1/3, plus, and this coefficients on this matrix, which we multiply by the coordinate x prime in the condition of the problem. The coordinates of the point in the new coordinate system denoted by the x prime 1, x prime 2, x prime 3, and we obtain the coefficients 2, 3, x tilde 1, okay, minus x tilde 2 minus 1/3 x tilde 3, and the second rows minus 1/3 x tilde prime is 2, 3. The answer is following. This problem is enough simple, but if you want to solve this problem, we must use knowledge about relation between new and old coordinate system. We must use all formulas which related the new and old coordinate system. And we repeat, the goal to solve this problem, to understand how connect the coordinates of the point in the old coordinates system with coordinates of this point in the new coordinate system. The main idea, and in my opinion, enough non-trivial, if you have an arbitrary point in the space. If this point move, the coordinates of this point obviously change. It's enough evident for us. But non-trivial thing that if change coordinate system, we can suppose the coordinate system is moved, but the point is stable. In this case, the coordinate of the point also change. For example, we sit on the bank of the river and see on the water, and water moved. And we can suppose with moving particle of the water connects the family of the coordinate system. And this coordinate system moved relatively u. And your coordinates change in this case. Your coordinate change. And the same idea, the moving is relatively. If we have some choose how to choose a coordinate system. And the coordinate of the point is a function of the coordinate system. This main idea, these formulas illustrated this enough deep idea. Any question about this problem?
Thank you.
The answer. Okay. This as a rule, what mistake in this problem? As a rule, a mistake in the calculation. In some work, some test work, anybody use the right formulas, but have the mistake in the calculation, and somebody use wrong formulas, and it's pity for me that I but understand the meaning of this formula, and you couldn't use these right formulas, and this first problem was hardest for you. Okay, and I suggest сколько времени остается? Полчаса? And we have a little time, and maybe we can consider other one more problem. One more problem. Yeah. Question?
Do you have the answers of the questions in a PDF file?
What? Repeat please. What question?
Answers the answers of the questions you solve in seminars and those which you don't solve, do you have the answers in a PDF?
Yeah. The problem, yes. We have in PDF, yes, but more simple for me to write on the desk. Yes, maybe.
But once you don't solve, we may have a problem in it, and I cannot solve. So it would be better if you.
Yeah, in my opinion, the sum mistake is typical, and I try to explain the typical mistake. Some of this problem, in my opinion, enough simple and not principle. For example, find the equation of the parabola. As a rule, the mistake which was done, the mistake in the calculation, but not typical. For example, find the equation of the parabola. We must use only definition of the parabola, and we can easy to solve this problem. In my opinion, the solution of this problem is enough simple. The problem, but and other problem is, for example, the fourth problem. Find equation of the tangent to the hyperbola. We can use only the formula for the tangent, and in my opinion, enough easy to solve. I didn't understand why you cannot you couldn't solve this problem. But in my opinion, the second problem more interesting. We have the conic, which defined by the equation y square minus xy plus 4 x squared plus 4 y square minus how to understand what the curve we have in this case. The first way to solve this problem use the formula which was done in the lecture and compute the angle rotation. How to rotate the coordinate system and how to obtain the canonical equation, how to kill these terms, how to find the angle of rotation. The simple observation, in my opinion, the simple way to solve, to note that these three quadratic terms can be written in the following form: y minus x squared. X squared Yes, explain. Explain. We can rewrite the quadratic part of this formula in the following form: x minus 2y x minus 2y square minus and we can define new coordinate, and we can introduce the new coordinate which equal this expression, which we can multiply some factor. If we can, we have the following formula: x is equal x tilde cosine theta minus sine theta, y is equal x sine theta plus cosine theta. And inverse expression which expressed the new coordinate in terms of old, this rotation on the angle theta. Inverse rotation, the rotation on the opposite angle minus theta. And we obtain the following expression: x cosine theta minus plus y sine theta, x minus x sine theta plus y cosine theta. And easy to see, we have rotation on the some angle. These coefficients, if we can to define the length of the vector 1 plus 2 square is equal root square of 5, and we can rewrite the expression x minus 2y in the following form: root square 5 x minus 2 root square 5y. And we can denote this expression by the for example x prime, and y prime is equal to divided 5 x plus y, and we obtain the following expression for rotation: x x is equal yeah, yes. I write in more detail this expression. I try not to use the formula and using more simple way to obtain the formula. We have the following observation. This expression is a full square of this quadratic form. And in this case, the other coordinate in the new coordinate system is absent. And in this case, we obtain that this curve is a parabola. And I try, yes, and I try exact formula for this parabola by naive way. By naive way.
Why did you use the rotation formula x equal x to the cosine of theta?
Yeah. This formula, if I try rewrite this expression in the following form, some constant rho x cosine theta plus y sine theta in the following form. Maybe in this form. I can choose this expression as a first new coordinate and as a second coordinate. I have two rotation. I choose this coordinate as the first, and I have two formula. One of them expressed new old coordinate in terms of new, and inverse formula, which express the new coordinates in the term of the old. If we have rotation on the angle theta, the inverse rotation, the rotation on the opposite angle, minus theta. And in this formula, I change sign in the theta. This plus cosine is an even function, and sine of cosine not change, but sine is odd function, and I must change the sign. Here we have minus, and this formula we have plus. In this formula we have plus, in this formula we have minus. Sine of cosine not changed. And in our case, I try to rewrite this formula in this form. We have two coefficients, and I want to rewrite this expression in the form cosine theta plus sine theta. I have 1 is equal rho multiply cosine theta minus 2 is equal rho sine theta. How to find theta? Easy to see that the rho square is equal 5. I can consider square of the first expression of square of the right side of the first formula and square of the right side of the second formula. This square, rho square cosine square, this rho square sine square. Cosine plus cosine square plus sine square is equal 1. And sum of these squares is equal rho square. And we obtain rho square is equal 5. And from this we obtain that rho is equal 5. After that we obtain that cosine theta is equal from this formula we obtain that cosine is equal the ratio 1 root square 5, and sine is equal minus the ratio minus 2 root square 5, the formula for the sine square. And final formula is the following: x prime is equal the ratio 1 root square x minus 2 root square 5 y, and y square is equal the ratio 2 root square 5 x plus 1 root square 5 y. We obtain the transition formula from old coordinate to the new. And inverse formula x, y, I must change the sign, the signs of the signs of the sign. And this sign and this sign. And I obtain this formula. We have two final formulas. And after them, I substitute this expression in this formula and obtain following expression: 5x prime square minus 6x is equal to this expression, and I substitute this formula and plus 2 times y, and substitute this formula. This. And easy to see, we obtain the following final formula: minus 6 plus 4 minus 6 plus 4 minus 2 root square x prime minus 12 minus 2 minus 14. Excuse me. Minus. Okay. And after them, we reprise this two term and this, and we obtain the following expression: 5x prime minus 1, 5, the ratio 5 root square 5 square is equal And we obtain the following formula. I'm not sure, maybe I have mistaken it. We have canonical system 5x2 square 2 prime square is equal and we have exact formula for x2 prime is equal x prime minus y prime is equal we have the parabola and easy to see that parameter p of this parabola is equal to divided 5 root square 5. And we can draw this parabola in the plane. But in your solution, sufficiently was to show that we obtain the parabola in this case, and this calculation reducing to this form give the answer, and easy to see that we obtain the parabola. The other way to calculate some invariant of this parabola, some invariant, enough to calculate determinant of this matrix, and understand the value of the determinant. The matrix of quadratic form the following: 1 minus 2 minus 2, 4. And determinant of this matrix is equal 0. It means that this curve of the curve of the parabolic type. But if you want to calculate the parameters of this parabola and find exact position of this parabola on the plane, we must do this calculation. Okay, any question? Thank you. This is enough hard problem, but enough. We have two, in my opinion, hard problem and two enough easy. We consider only hard problem. Okay, let's try to solve the same problem, but for the case of surfaces. The theory of the surfaces in the space is the same on the theory of the curves in the plane, and many common general approach to solve the problem of the two types. I haven't any time, and I try to consider only one simple problem We have the following family. We have the following family of surfaces, and lambda be the real parameter. And the problem the following: define type of these surfaces as function of the lambda. How the type of these surfaces depends for the lambda. For example, let's consider the case lambda is equal 0, lambda is greater than 0, lambda then less is 0. First of all, let's lambda is equal 0. What we obtain in this case? Let lambda is equal 0. Let's substitute 0 in this expression, and what we obtain? X squared is equal 0. What is the surface? X squared is equal 0. Easy to see that equivalent that x is equal 0. What does it mean? What we obtain in this case? Easy to see that we obtain coordinate plane. We obtain this coordinate plane y, o, z. And in this case, we obtain the coordinate plane. This answer is evident, but this answer is wrong. Why this answer is wrong? What difference between x squared is equal 0 and x is equal 0? In geometrical sense, we haven't difference. We have the same geometrical object, but from algebraic point of view, we have various objects. In this case, we have double coordinate plane, double. And we have two coordinate plane which we identify. For example, if we have such equation, x minus 1 is equal 0. And in this case, we have quadratic equation. And in this case, we have two roots, but these two roots is coincide. We have double root. In the same way, in this case, we have double plane. And this double plane is a quadratic surface. But this equation is defined as a plane. And we will consider as distinguish double plane and plane. In this case, we obtain double plane. Second case, lambda greater than 0. What we obtain in this case? X squared plus lambda y squared plus z squared is equal lambda. Lambda greater than 0, let's divide it from lambda, and we obtain x squared divided lambda squared plus y squared plus z squared is equal 1. Oh, I'm sorry, divided lambda. What's the surfaces we obtain? What is? lambda is greater than 0. We can rewrite this expression in this form. Easy to see, we obtain ellipsoid. And easy to see, to draw this ellipsoid. The size of the x x parameter a is in general equation of ellipsoid. We have a is equal root square from lambda, b is equal 1, c is equal 1. We have the ellipsoid with such parameters. And the case when lambda less than 0, we obtain the following formula. Y square plus z square minus x square divided root square minus lambda square is equal 1. And we obtain what we obtain. We obtain the simple hyperboloid. And we can write if we obtain x is equal 0, we obtain, in this case, we obtain the circle with radius is equal 1. And we have two hyperbola. In this case, we obtain a simple hyperboloid. And in this case, we obtain paraboloid. Oh, we obtain ellipsoid, I'm sorry. Lambda less than 0. Lambda less than 0, and I divided left and right side onto lambda. Yeah, and yes, and in this case, this square of the minus lambda is equal minus plus lambda, and the square of this expression. After division, we obtain the following expression: x square, the ratio x square lambda plus y square plus z square is equal I'm sorry, lambda yes, I divided by lambda. Lambda is equal 1. Yes, lambda is equal 1, and this lambda less than 0. And I rewrite this expression as minus lambda. Minus lambda greater than 0. And I can consider root square from this expression and square of the root square. But we have minus between this term. Yeah? We are right in this form, yes. And the expression, this I can denote by some parameter a, and we obtain this formula y squared plus z squared minus x squared divided a squared is equal 1. We have canonical equation of the simple hyperboloid x squared divided a squared plus b squared minus z squared divided c squared is equal 1. Easy to see if we change the names of the coordinate system. Let a be the new x, z be the new y, and x be the new z. We have some rotation, x to y, y to z, and z to x. After this rotation, this surface transfer in this canonical. But other way, we can consider the new position on the surface in the space, and the line of symmetry, straight line of the symmetry, in this case will be OX, and our hyperboloid has the following form. But I recall the canonical draw is the following: z, x, y. After this rotation, we obtain z z transfers in the x transfers in the y, and y transfers in the z. And after this rotation, we obtain this surface. This is other way to obtain the draw of this surface. Do you understand? Any question? Thank you for your attention. I haven't any time, and we finished our seminar. Thank you. Goodbye.